Hello, you're welcome back. All right, so now still on calculus. Okay, so we're going to be looking at the other part of calculus, okay, which of course is integration. All right. Already, I remember telling you when we introduced calculus that calculus is being divided into two parts. We have the differentiation, the differential calculus, and the integral calculus. And we said that for the differential calculus, we actually split a large amount of change into tiny or very small rate of change, but in integration we actually gather that those small rate of change to to get our large rate of change. All right, so now what is integration? Now in a simple term we can say that integration is the opposite of differentiation. So if you are not differentiating, then you are integrating, so they are opposite. Now, anytime a function is being differentiated, anytime we differentiate a function, the only way to get back to the original function is to integrate. And that is exactly what happened here. So invariably now, let's say there is a function, as we can see, let me get to my board. Let's say you have y was, you differentiated the function, right? Remember, anytime you differentiate a function, you still have a function. That is the derivative. Every time you differentiate a function, you have a derivative, of that function, and this is still a function. Let's say you differentiate a function, the y, the x, which probably gave you another function, f of x. Now, if I want to get the function that I differentiated, is simply the only way I can actually get my original function is to integrate. So if the y dx is equal to f of x, then my y, because it was y that I differentiated for me to have f of x. So if I want to get my y now, I now have to go opposite. And the opposite is actually integration. So I now have to do the integral value of f of x with respect to x. The same way we integrate with respect to a variable, we differentiate, please pardon me, with respect to a variable. We differentiate y with respect to x. We also integrate with respect to x. So this is the symbol of integration, right? So now it is the way we pronounce this. We pronounce this as the integral value. Integral value, of course, of the function, which is f of x. Then with respect to x, so I hope that is well understood. Okay, so please take note of that. Now let's go to that note. Now let's look at types of integration. Now integration is of two types. Basically we have the definite integrals, and also we have the indefinite integrals and have the definite integrals. So what is different between these two types of integration? Now the indefinite integrals, we integrate without boundary or limits. So that means if you want to do the integration, there is no boundary to your integration, so without boundary or limit, so it's indefinite. All right, so that means anytime you are being given an integral value without limit or like what we have here, there's no limit, then or boundary, then that is indefinite integral. But anytime an integration is within a limit, that is definite. So anytime an integration is within a particular limit or boundary, so that's going to be what? Definite integrals. Definite integrals. So that means we still have our integration sign, but there's going to be limits, the upper limit and the lower limit of whatever we're integrating. So at the end of the day, after integrating this particular function, they will now subject the limit of our integration to have a numerical value. Okay, so now let's now go to here. I'm not going to be applying first principle in integration, okay? So what we just do in integration is to get the formula of integration, okay, based on the function. So we are looking at standard integrals. Standard integrals. Okay, so I'm gonna give you some few, then of course later on I'll give you more. Let's start with the integral value of s raised power n, the power of x, with respect to x. Now remember, integration is the opposite of differentiation. Okay, remember in differentiation, if we were to differentiate this, I'll take the n at the back of the x, then I subtract 1 from the power. Okay, but here is the opposite. So I will rather have to add 1 to the power, then I divide by, okay, n plus 1. Then anytime you integrate, always include the c, okay? The c here is what is known as the constant of integration. C is the constant of integration. Okay, so I hope that is well understood. All right, now that's number 1. Number 2, what if we have, okay, the power of x that has a coefficient as respond n with respect to x? So how do we do this? We take the coefficient to the back of the integral value, then we can now integrate the function of x. Okay, so it shows that anytime a function has a coefficient, the coefficient always go at the back of the integral value. All right, so now can now integrate. This is going to be a, of course, the integral value of x, of course, is s raised power n, that's s raised power n plus 1 divided by n plus 1, okay? Then don't forget the c, okay? The constant of integration. Can use c, can use k, but you must include that. Okay, so now I hope that is well understood. Okay, let's proceed. Now let's look at some trigonometrical function, right? Trigonometry. So this is number 3 now. Let's say you have the integral value of cos x, then with respect to the x. So if you are to integrate cos x, all right, you will have sin x. But if you are to integrate sin x with respect to x, then the integral value is gonna give, will give this time around negative cos x, unlike what we have when we, okay, in differentiation. Anytime we actually find the derivative of anytime we are asked to find the derivative of cos x, we have minus sin x, but in this case now the integral value of sin x will be minus cos x. Okay, so I hope that is well understood. All right, then number 5, let's look at the integral value of, this time around, 1 all over x respect to x. Okay, so in this case we are gonna having ln x plus c. Remember, the integral value of ln x is 1 over x. Now the integral value of 1 over x would not be ln x. I hope that is well understood. Okay, so now there are other standards. Okay, I will not fail to include the integral value of a constant. Remember, the derivative of a constant is always 0, but in this case, if you are being given a constant, let's say a with respect to x, okay, the integral value of a constant is simply ax, constant a. So whatever constant you want to actually integrate, all you just need to add the variable, okay? Of course, the variable is x to it. That's going to be as plus c, for example. Okay, if you are being asked to integrate 5 with respect to x, so what you have is going to be 5x plus c. Then let's look at the integral value of exponent. The integral value of exponent x, okay, still remain exponent x, then plus c. Okay, so there are a whole lot of standard derivative, a whole lot. Okay, I will still bring more, okay, as we progress in this tutorial. But now let's now go to the integration. I mean standard integral values. Okay, there's a whole lot of standard integral values, so I will be bringing them as we go through the tutorials. But let's get to techniques of integration, different techniques for different function. Okay, so now number one technique we're going to be looking at is, okay, we're still going to look at the sum of functions. The sum of functions. So let's say you have sum or difference of function. For example, let's say you got y to be equal to u, which of course is a function of x, plus v. Okay, I don't need to put y. Is the integral value. So let's say I've been given the integral value of u, a function of x, then v, also a function of x. Okay, then you have to integrate this with respect to x. So sum of functions. So because they are sum simple, you integrate them, you find the integral value, okay, and you add it. So it's something as finding u of x with respect to x, the integral value of u of x with respect to x, then plus the integral value of v of x with respect to x. So for example, if you are being given this, find the integral value of 2x raised to power 3 minus 3x squared plus 4x minus 1, all with respect to x. Solution. All you just gonna do is to integrate them, okay, one after the other, and of course add and subtract them. Okay, so this is something as finding the integral value of 2x squared with respect to x plus the integral value of 3x 2x cubed, please pardon me, this 2x cubed, okay, 2x cubed with respect to x, then 3x squared with respect to x plus the integral value of 4x with respect to x, then minus the integral value of 1 with respect to x. So of course, let's now, you know how we do this, okay? This is gonna be 2x raised to power 3 plus 1 all over 3 plus 1. The same thing happens here. This is gonna be 3x raised to power 2 plus 1 divided by 2 plus 1. Then plus 4x raised to the power of 1 plus 1 divided by 1 plus 1. So of course this is a polynomial, okay? The integral value of 1, remember, is going to be 1x. Then I have to add my constant of integration. So my final answer now is going to be equal to 2x. Of course, this is 3 plus 1 is 4. 2 cancel itself 1. Cancel, divide 4, that is 2. So I'm left with just, that's s raised to the power of 4 divided by 2. Then plus this 3 here, 2 plus 1 is 3. 3 cancels 3. So I'm just left with x raised to the power 3. Then plus, here this 2, okay? 2 divided by 4, divide 4. That's 2. So I'm going to have 2x raised to the power 2. Then minus x plus c, okay? So we'll look at more of this technique. So this is sum of functions. So we're going to look at other technique, function of linear function and some other function. And that will be the next video. See you in the next video. Thank you very much. Hello, you're welcome back. All right, so now still on calculus. Okay, so we're going to be looking at the other part of calculus, okay, which of course is